the observer pattern that we just discussed actually exhibits quite many good design properties. For example, modularity. We actually separate between subjects versus observers into different modules, different classes. And also polymorphism, we actually got a polymorphic collection of observers. Dynamically, it could be any of the descending classes type from the observer. And also dynamic binding. So every time if this was any change from the subject side, we can call notified. In which case, whenever we call dot updates on a particular element in the polymorphic collection, dynamic binding is going to make sure the correct version of the updates will be called, right? So that's kind of the ingredients that we talk about for the observer pattern. Having said this, the observer design pattern actually will be quite limited in terms of the problem context it can actually solve. Let's see exactly what I mean by this. So let's remind ourselves the observer design pattern is very reasonable or even elegant solution to building a one-to-many relationship. So here we got one subject and many observers, as many observers as you like, as long as you can maintain the list of the observers in the subjects. So one subject and also multiple observers. But let's generalize the context for the problem over here. Let's say we got a many-to-many relationship. That's the most general context you can think about. Let's say we got multiple subjects and multiple observers, right? Let's see how things might change really dynamically and see how if the complexity is really still manageable. Let's say we got multiple weather data, we got multiple subjects that are actually maintained by weather station. Actually, that's actually more realistic because realistically, you shouldn't just get one piece of data. You might get different sensors, in the same weather station. So it actually makes sense. We got multiple subjects in this case, in the more general context. And we got each application, each observer observes all these weather data. So now we're talking about each observer should be attached to multiple subjects. So now rather than simply just get a single weather data attributes, you may need to get maybe an array of weather data list, right? In that case, you have to make sure whenever you create your weather data, whenever you initialize a application objects, in that case, you have to make sure you actually attach yourself, the current, into every subject that's actually passed into the arguments, right? That's something you can see the complexity is already increased just because of this. So now every application still stores the latest measure only. You want to make sure, even though you're observing multiple subjects, multiple weather data subjects, but you still want to make sure you always keep your data up to date. How can you do that really, right? And so whenever some weather station updates the temperature, for example, some of the data, in that case, you want to make sure all the relevant subscribe application, all the observers actually should update their temperature. So now this part here, to be honest, is really similar to how the observer pattern works. But now the problem is, but how do we manage the observer side? So now, not only that, on the subject side, we got a list of observers. But from the observer side, we also got a list of subjects for each application, right? That's the complexity. How can the observer pattern solve this general problem? That's the question. Each weather data maintains a list of subscribed applications. So that's the new bits. We want to make sure we got a list of subjects. And also, each application is also subject to the multiple weather data. Yeah, beg your pardon. So this part over here, each weather data maintains a list of subscribed application. This is the same property as the observer pattern. But this second item here is the new bits. We want to make sure every application is also subscribed to multiple subjects. That's the new bits. Okay, so now let's talk about why this would be problematic. So think about what happens at the runtime when you build a many-to-many relationship using the observer pattern. Okay, before I show you the diagram, once I show you the diagram, it will definitely make sense. But can you imagine that if you got multiple subjects on the one side and you got multiple observers on the other side, how would the runtime links look like dynamically? It will look like something like this. Okay, let's talk about this quickly to see the drawback for the observer pattern for solving this general problem here. So what we are saying is on the left hand side, we actually got all the subjects, right? So you can think about over here. Let me use maybe yellow here. You can think about this part here is simply all the subjects over here. So we got multiple subjects. We got subject number 1, 2, all the way to M. We got M subjects, or M weather data objects over here. And then we got different application objects. We got application number 1, and also we got application number 2, and also we got all the way to application N. So we got M subjects and N observers. So that would be application N. So now let's see what the complexity is. So let's say, for example, just for application N, just for application number 1, what's happening over here is you want to make sure every weather data actually has a link to this particular application, right? You can see there's a link over here. There's a link from application here. Here you can see. Okay, let me show you again. From weather data 1 for the subject, it should contain as one of the observer application 1. For weather data 2, second another subjects, it should also contain application number 1 as one of the observer, and etc. Right? You can see for every subject, each one of them should really contain the application 1 as one of the observers. And similarly for application 2 and application N. And this link over here is actually bidirectional. I just didn't draw it up. It would be too messy. You can think about for application 1, you should also link back to WD1. You should also link back to WT2. Also link back to W, all the subjects over here, right? So now let's think about the complexity for this graph over here. What will be the overall complexity? Well, this will link back to what you learned in 2011, the data structure course. Thinking about this is more like a graph at a runtime. So each object over here is like a nodes in your, or vertices in your graph. Okay, and then each runtime link is like a edge. That's edges. You know, that's between the nodes. How many edges are we talking about as the complexity over here? Okay, so hopefully you will be able to answer me quite easily. So in the worst case, it's going to be basically for every subject is going to link to the number of the observers. So it will be basically n multiplied by n. So this will be the number of subjects, and this will be the number of observers. Right? Hopefully this is quite easy for you to see. So that's about the complexity, right? Let's see exactly what's going to happen when you talk about extension. Every time you want to judge about to see whether a design is really desirable, always think about changes to your design. Let me give you 2 examples. Let's say you want to the complexity of adding a new subject. Let's say I want to add a new subject, for example, over here. Let's say I want to add this one subject here. Let's say application. Oh, sorry, subjects, not really observer. Let me do it again. I'll do this observer in a moment. Let's say new subjects. Let's say if I add a new subject over here, let's say WD, let's say M plus 1. Okay, that's a new subject over here. So now, how many more edges should I really add in order to make sure the completeness? Well, I need to make sure this is actually include application number 1 as one of the observers, and also includes application number 2 as one of the observers, and also all the way to application N, right? So I need to add 1, 2, 3, all the way to N, because I got N different observers. So that will be big O of N, depending on how many observers you have or how many application objects you have. Let's do something very similar. What if I want to add a new observer rather than new subjects? Okay, let's see this. What about we want to add a new observer? In that case, for example, let's say over here, we already got N observer. In that case, I'm going to get, let's say application, let's say N plus 1, for example. That's what I want to add. Well, in this case, I want to make sure this particular application is actually included as an observer by all the existing subjects, which means this one has to include it, and this one has to include it, and also all the way to WD, n minus 1, and also M. Also, of course, M plus 1 as well, but that's okay. You can see it's getting really messy over here, right? But you can see what the upper bound should be depending on how many subjects you actually have, big O of N. So this page over here, the main reason for showing you this is the observer pattern really works well when you only got a single subject. But now, when you actually got a very general scenario where you got multiple, you got an arbitrary number of subjects, you can see the links that you will have to manage. You don't necessarily actually have to keep track of all the links all the time. But in case anything goes wrong, in that case, how can you really debug and try to see how the links are being managed, right? In that case, you really like a more elegant solution than this. So this one over here, in terms of extensibility by, for example, adding a new subject or adding a new observer, is terrible for solving this general problem over here, right? So that's the answer to what the limitation is for the observer pattern. So we do deserve something that's better. Okay, we'll speak about it in the next video.